who came out tonight, I'd like to invite you to our screening of The Visit tomorrow night at New School. If you bring anything from the gift bags you'll be receiving, you can come in for free. So that's going to be a great screening too. But now, of course, there's a panel discussion, and I'd like to invite up our moderator, Nicola Twilley. You may know her as for her blog Edible Geography, or her award-winning podcast Gastropod, or for her articles in The New Yorker. And she's now become obsessed with refrigeration, is writing a book on the subject, and you can sample her edible smogs at our closing party next week. So, Nicola?
Thank you. Are we going to maybe have seats, do you think? Should I? Yeah, awesome. So I am going to invite up three. You want to tell me where to be? Yeah, okay. I'm going to invite up three much more interesting people. So David, Sue, and John, why don't you come up and I will introduce you. Oh, yeah, please. I think we're loud. Oh, see. Yes, please. Awesome. So I'm going to introduce them. I have a few questions that are basically just excuses for them to tell us interesting things. And I will also open it up to questions from you guys. So please, we'll jump in after I've had the chance to ask a couple of questions. So on my right, I have Sue Reinhardt, a media artist. From her early video work 2 decades ago to feature films, Reinhardt has worked across a really wide range of approaches: dramatic, experimental, installation, documentary. Her recent work especially reflects her interests in science and ecology and natural history. Her film Cardia was awarded the Alfred P. Sloan Feature Film Prize at the Hamptons Film Festival, and her most recent documentary film, The Messenger, is now playing in festivals worldwide and will be featured on Sunday evening at the Rubin Museum of Art as part of this year's Imagine Science Film Festival. Okay, next to Sue, we have David Grinspoon, who is a senior scientist at the Planetary Science Institute. He is an advisor to NASA on space exploration strategy. His research focuses on comparative planetology with a focus on climate evolution on Earth-like planets and what the implications of those climates are for habitability. He has also studied, written, and lectured widely on the human influence on Earth, as seen from the cosmic perspective. He has 2 books out and one more soon to come. So Venus Revealed and Lonely Planets, The Natural Philosophy of Alien Life are the 2 you can buy now, the latter of which won the 2004 PEN Literary Award for Nonfiction. And the one you have to hold out just until next year for is Earth in Human Hands, coming out. Okay, and then last but in no way least is John Bedard, a New York-based Google engineer working in the super exciting field of virtual reality in education. Currently working on an education tool that will allow teachers to take students on a virtual reality expedition to any place imaginable. Amazing. So we get to maybe try that out, or at least see some of that anyway. So I'm going to start, because the theme of this year's Imagine Science Film Festival is air. I'm going to start with a really basic question, which is, how do each of you look at air and atmospheres? And even extrapolating from that, how do you go about making the invisible visible? And I guess we can go in order.
First. Okay. It's a very interesting question. I mean, I think air, in terms of representation, when you think of representing something, it's like things Western culture and art have grappled with for centuries. It's like an emotion. It's like the unconscious. It's like, how do you represent something like that? So I mean, actually, I have two clips that I'll show, and they're not really attempts to represent air. That's kind of part of just what happened in them. And I think in my case, because air is this intangible thing, it becomes more something that's the result of air or the impact of air or the absence or the presence of air. So that's how I've ended up representing that. Okay, so maybe I'll just set up the first clip, which I guess will screen on those side screens. It's actually a 1 minute long image from the film that is playing Sunday night, The Messenger. And this came about as a result of a collaboration with some scientists that I just kind of cold called one day, like 911 scientist, because I needed to create an image that I couldn't do without their assistance. Anyway, so yeah, I'll tell you more about it after, but yeah, so we can play that first one called Bird, if you don't mind. So that image is, thank you. It was done in collaboration with the University of Western Ontario, where they have a hyperbaric wind chamber. And they actually use it for biology, and they study birds in flight. And I wanted an image of bird in flight without, I mean, these are tiny birds that they're not like big things that you can film from an airplane or anything. And we also used a slow motion camera. So that's how that image came about. But in terms of air, I mean, it's the absence of air that I think suggests air in that image. So you get the essence of it more than in a poetic sense. Okay, and actually maybe I'll pass this along, and I have one other that I'll show, but I'll come back to me so I'm not doing the whole thing.
Oh yeah. Does this mic work? Oh, cool. We can do harmony this way. Okay. Yeah. Well, I'm as was mentioned, a planetary scientist. I do comparative planetology. So one way I think about the air here on Earth is as a specific example of a more general phenomenon that is different in different places on different worlds. And you could say that we're sort of lucky that the air here on Earth is the way it is because it's so conveniently habitable for us here. But if you said that, you'd sort of be wrong, because it's not really a matter of luck. Because in a true way, if you look at the long history of life and the planet, we've kind of co-created the atmosphere. We meaning life, the biosphere, not we industrial human beings. We're doing nearly the opposite right now. But in fact, it really, the air is the result of a partnership between the biosphere and the solid Earth. And I'm real interested in that. Actually, I had are those slides queued up? I'm not going to give you a lecture, but well, it doesn't matter if they're not.
He's got it.
Oh, yeah. If you're, what I've focused on is comparative planetology, and this is sort of a family portrait of our solar system, and this is really a product of our times, the time we live in. It's something that that's very new, that we can look at our world as one among a family like this. This is something that's happened in my lifetime. When I was 2 years old, the first interplanetary spacecraft went to the planet Venus. And this is something I became very captivated with. The first Mars lander, Viking, happened when I was in high school, and then by the time I was at university, I was able to participate in some of the earliest missions to Jupiter, Saturn, Uranus, Neptune, and just this year, we managed to get the New Horizons spacecraft after a 9-year flight. I met a woman the week of the launch in 2006, and married her this year, 3 weeks before the encounter. Hi, babe. And so now we've been to Pluto. And these are, for those of us in the community, these are events that have sort of unfolded through our lifetimes, and this perspective is very new, and we're almost still trying to figure out what it all means. But one thing it's done is given us a whole new perspective on our home world and an ability to see Earth as one particular example. And just really quickly, the next slide shows you this trio of worlds. I've been specifically very obsessed with Venus, Earth, and Mars, because Venus and Mars are our two nearest neighbors, and they're also both places that are similar, the most similar to Earth of other planets we know, but different in really weird ways. They've diverged. I have 3 more slides. I'll show you really quickly. One more. The next one, please. These are landscape pictures. The top and the bottom are the first ever landscape pictures we had of Venus and Mars. Both, again, events that I remember from my youth very clearly when those came in. And that middle picture is one that I took, which is sort of a typical picture of the surface of the Earth, if you had to take a typical picture. And the interesting thing is that 4 billion years ago, when these worlds were all young, they probably all looked the same. They all were oceanic worlds, and Venus and Mars have both diverged from that track. And studying them has taught us that planets evolve, and that an Earth-like climate is not something you can take for granted. The planets can start out that way and diverge, and this divergence is something that I've really tried to understand, and is one of the driving questions that has led me in my exploration of this subject. Anyways, I think I better pass the baton here, but we can return. Yes.
Okay, great. All right, so I guess this thing is working. We've proven that. First, I'd just like to say thanks for having me here. This is really cool. This is kind of new to me, so I hope I don't screw up. Anyway, I think I'm going to follow the examples of my 2 esteemed colleagues here and show my quick video, and then I'll make up some reason how it ties into viewing the invisible. So if you could please play the video.
You could pick anywhere in the world that you want to go. Where would you want to go?
I would like to go to the moon.
Thailand,
Ancient Greece.
India,
to Nigeria, my homeland.
One or maybe all of the 7 wonders of the world. When you explore different places, you have the chance to actually learn something new.
You want to be able to show the kids that there's something outside of your community that you could go to and learn from, and that there's other places you can visit.
All right, so let's do our objective and we'll talk about the lesson for today.
We're gonna take a field trip to Verona, Italy to see the place where Romeo and Juliet lived.
I'm going to take you on this field trip under the water. Okay, you guys ready? Pick up your devices
and look in your cardboard.
What is that?
I see a shark.
Whoa!
It allowed us to go somewhere we wouldn't normally be able to go.
Are we in China?
This is the Great Wall of China.
We got to see the place itself, so we could actually understand what she was talking about.
How long would it take to walk the length of the Great Wall of China? So much more enriching than just showing them a picture or just having them read about it.
This device can actually make us go to places that we've never been before.
It brings the lesson to you. You have to see it for yourself to believe it.
There's so much other places to see, so you know that it's never going to end.
So that's Expeditions. That's the product that my team is currently working on. Oh, thanks. Thank you. So the question was, how do you view the invisible? And I'm going to view the question, I think, through the lens of education, because this is kind of what I've been working on for a long time and what I care about. So I'm going to rephrase the question a little bit. how do you teach a child about the invisible? How do you bring something so ubiquitous as air that we all stare through every day and show that to a child in a way that's interesting to them and that actually teaches them about something? And actually in this product that we're developing, we have a series of tours where we show children the molecular composition of the air. And we go through a series of 3D virtual spaces where the child can actually see, it breaks down what the air is composed of. It shows them what mist is and how water molecules kind of intermingle with air molecules. So I think this is a very interesting tool that we're working on. And it's one way to see the invisible.
Excellent. So there was a recurring theme there, which was, or a little bit, I'm going to pull one out anyway, which to me was something about seeing air better or seeing something better, seeing our own place and our own air better through looking at something else. That in many ways those children can learn about the world by seeing something else, learn about their world by going somewhere else, that we can learn about our atmosphere by looking at Venus or Mars or somewhere else, and that in a hyperbaric chamber, that's where you see air. And I wonder I guess this is a question about perspective and needing to look elsewhere to how our perspective here on the ground changes what we can see and how we can try to not be stuck in that perspective, I guess. We don't have to go in order this time. We want to start in the middle.
I can go. Well, one thing you just said reminded me of the famous T.S. Eliot line about I'm going to botch it, but at the end of all our explorations, returning home and seeing it for the first time. And I'm sure there's an English major in here who can get it just right, but that's the idea. And okay, so well, but at least I was close enough so you know what I'm talking about, so that's good enough. Anyways, there's a difference between science and exploration. In that really comes across when we look at what we learn from missions to other planets, because we always set out thinking that we're going to learn something. When we justify a mission to Mars, we have to tell NASA, here's the questions we're going to ask, here's what we think we're going to learn, here's how we're going to answer those questions. You have to do that to justify spending $1 billion on a mission, but always it happens that we find things we weren't expecting, and we then realize that the questions we went there to ask were not the ones that we thought. And there have been a lot of things we've learned about the atmosphere of Earth, really important things that we thought that we had in hand that we only discovered about our own planet because we went to other planets. And a really important example, I'll just give one, is the destruction of the ozone layer. We first learned about because we were sending spacecraft to Venus and looking at what was happening in the upper atmosphere of Venus and trying to understand what was happening to the oxygen up there. There was this big mystery. There should be more oxygen because most of Venus's atmosphere is carbon dioxide. That's why it's so bloody hot there, as you know, CO2 climate. And so ultraviolet light from the sun breaks up CO2, so you should expect a lot of oxygen in the upper atmosphere of Venus, but there isn't any with our spacecraft. We couldn't find it. So there was something eating oxygen. And then some couple of really smart scientists at Harvard were doing some experiments in the lab, and they realized, chlorine eats oxygen really, really efficiently. Maybe there's a little bit of chlorine up there, and they found it, and that was what was making the ozone and the other oxygen compounds up in the upper atmosphere of Venus go away. And then somebody else, actually this involves James Lovelock, the famous founder of the Gaia hypothesis you've heard of. He was doing these experiments and realizing by the way, we're putting all this new chlorine up in Earth's upper atmosphere from these CFCs, these refrigerants. Everybody says they're totally safe. I wonder if that chlorine is doing it. Oh, wait a minute. Chlorine destroys ozone. And they figured it out because of studying this arcane, abstract, seemingly purely curiosity-driven question on Venus, and sounded the alarm. And then it became this great example, actually, of the Earth, the people of Earth getting together and deciding we're going to stop doing this and solve this problem and fix our atmosphere. And it's working, by the way. So it shows that we are capable of having that kind of realization and making that kind of change. It's a hopeful example, but it also is an example of something that we absolutely learned because we went to another planet and didn't actually even know what we were going to find there, and we found something very important about our own. So,
wow, that's actually pretty sweet. So I have a really cool example that I want to share with you guys, and it's kind of talks about how perspective colors who we are and how we live our lives. There's a project called To Be Another, and it's an art project. You might have heard of it. But what it is it actually lets you live inside the skin of another person. It lets you be another person. And the way it accomplishes this is through, you're wearing a virtual reality headset, so you can see through their eyes. They're kind of wearing a camera. And you also have motors like strapped to your body. So when they move around, you're also moving around. And they've done this with men and women where for a little bit you can be a woman. And that was really interesting. You should watch the video because people start taking their clothes off. But they've also done it with children and adults, which I think was really fascinating. And they did it with a handicapped person and an able person. And yeah, the results I thought were just stunning. And it was a really good example of perspective and how it can affect you.
I'll just add one comment. It's just interesting in the films and also what David was saying. I mean, we talk about the atmosphere and air and these worlds so far away and beyond us and this expanse and this vastness. But in terms of perspective, the other thing about air is, I mean, from where we sit here, we're all breathing. And it is at once vast and boundless, but at the same time, it's the most intimate thing that we're doing, and we're doing it all the time, and it's life, right? So in that sense, it's kind of those two huge things are hard to kind of reconcile. Anyway, that's all.
Can you show another clip?
It doesn't.
It doesn't have to relate. My next question wasn't going to.
Okay. Well, I did have one other example of air. It's from a 15-minute film that's an experimental film, quite different from the documentary. It's showing Wednesday night. And it's a piece that's a first-person testimonial. It's a 15-minute film, and it's historic. It's kind of a meditation about memory and meaning and scientific discovery in the time of war. So it's just a 1-minute piece, and it has air in it.
We observed that it was completely clear, and the meteorologist made that judgment, and he radioed that back to the strike ship, the Enola Gay. And then we went into our power lockdown, and we were out of there. And of course, when a mushroom goes up 40,000 feet, you're going to see it for a long time.
Yeah. One thing about that with the juxtaposition of those two images, I played that wave backwards, and also the sound is backwards. And I think, as an artist, a creative person, I wanted to find an image that was impossible because I felt that moment in time, once we had that change. It was irrevocable, like the world changed. We can't go back. So the waves going backwards, just something that came to me as just this idea of something that's impossible. But also I was just talking about breath and air, and it's also like a kind of a gasp or an exhale, or the sound of it is also this kind of grieving, breath again. So anyway, that's it.
Well, so that actually, that gives me a segue. And be thinking of your questions, people, because it's nearly your turn. But I was going to say, all of the films we saw tonight have this sort of, they're trying to leave the planet, or the majority of them, for good or for bad. Some of them show the sort of the pain of that separation. But for most of us here in the room, I'm going to say that that's never going to happen. So I wonder, what tools can you guys offer as a way to sort of help get us off the planet, and to experience these other worlds and other atmospheres, escape our own atmosphere, even though we never actually will?
I want to team up with this guy because I think we will experience that. By combining my spacecraft and your virtual reality. Really, we're going out there and gathering the imaging and the other data, and you guys are learning how to put us in those other spaces. I think we can all go.
Yeah. This question, I love this question because I work in this field, virtual reality, and I think that's a very good way of visiting other worlds without actually going through the hassle of building a spaceship or whatever else you have to do. But I want to talk about some things that people don't usually talk about with virtual reality, because it's a huge field and there's lots of cool things. People usually talk about the headset, the thing that goes on your face. But there's other things that deal with your other senses. Humans have 5 senses. The headset really only handles 1, vision. And then you got headphones on, obviously, which is your ears. But there's things for taste. There's actually a thing that you can strap to your face, and if you're walking through a jungle, let's say, it will inject forest smells into the mask so that you're smelling the forest. It's really weird. It's not a joke. And there's also something that I really love called haptics, and this is kind of a branch of VR. And I don't know if you've heard of a haptic vest or haptic gloves, but what they allow you to do is when you're in the virtual space and you're touching something, it actually feels like you're touching that thing. It gives you kind of a feedback, like a buzz. And I tried a haptic vest one time, and it was really cool. I got shot in the chest, and it felt like I was getting shot. Probably not totally accurate, but it was very interesting. And then the third thing that I want to mention, which I think is really cool, are these VR treadmills. And what this means is when you're in the virtual world, you have to actually walk in order to get from place to place, which I think is great because it's going to usher in this new age of really in shape gamer nerds. And I think that's going to be amazing. So
it's what the world needs.
I just have a brief comment. I think in terms of tools to experience other worlds, I think we all have one tool, and it's actually the name of this festival. It's the imagination. I think the very act of imagination is the most powerful thing to experience other worlds. So,
do we have anyone brave enough to ask the first question? I can't see anyone, so you'll have to Oh yeah, go. Oh, there are mics in the audience. Yeah.
Hello. Just related to this last question, when I was a little kid, I liked to watch this show called Dragon Ball, and I remember that when they were traveling in space, they could tune the amount of gravity that they will feel in the spacecraft. Any thoughts on how to feel the lack of gravity through virtual reality?
That's really interesting. I think that's something that's hard to do because gravity is hard to escape from. But have you ever seen the VR things where you're going down a roller coaster? Well, yeah, you should try it out because if you're seeing yourself go down a cliff or go off a roller coaster, you get that familiar feeling in the pit of your stomach, and it's really visceral. And I think that, things like these, this tool, and things like the haptic vest, which just make you feel a lot more viscerally, those are the things that are going to get better and better and help take you to those cool places. But yeah, anti-gravity, we got to figure that out. Google should work on that.
Yeah, I mean, gravity's a hard one because, I mean, when you're building a spacecraft or a habitat, is we don't actually know how to control gravity. We know how to control air pressure and temperature in an actual environment, except we can sort of control gravity, because famously you can spin a spacecraft or a space station, and you've probably been in those things in the in the carnival where you get in the thing that spins and you get glued to the walls, and that's really fun. And I actually did astronaut training and got to go up to 6 Gs in a centrifuge. That was a trip. But But that will always be difficult unless we actually someday learn how to control gravity. But I think we may never, because it turns out that it's part of the geometry of space-time. It's not something you can just sort of tune.
By doing these tricks of rotation, but you can't decrease it, right?
Right. Exactly. Exactly. Yeah. There's no way to decrease it. Yeah. Oh, actually, that's not quite true. If you can drop, right? But you can't do that for very long.
That's your reality. You have to fly really, really high, right, to do that.
Yeah. Exactly. For a brief period of time.
Actually, I just want to add one more thing. There was actually an art installation that went through MoMA where you'd lay down on this kind of bed and you'd flap your arms, and what you'd be seeing it was a virtual reality thing. I read a lot about this random stuff. But anyway, what you'd be seeing is you're a bird flying through Manhattan. And I never got to do it. I tried so hard to get there on time to see it, but I was traveling and stuff. But I had a few friends who went, and they told me that you got this real sense of like you're flying through buildings, and they thought it was amazing. So,
thank you.
Yeah, hi. For historical reasons, we're very geocentric when it comes to the size of the Earth, being 8,000 miles in diameter, but the atmosphere extends far out. In fact, the exosphere comes 6,000 miles above the surface of the Earth. So really, the diameter of the Earth is like 20,000 miles. Is there any way that you can think to get that across to people, to emphasize how important and how big really the atmosphere is? Because that's part of the Earth. We just think the Earth is as big as the rock of the Earth, but really it's much, much bigger.
I think you should put a price tag on it and sell it as real estate. Then that'll get people's attention.
Air rights.
Air rates, yeah.
That's another tough one because there isn't any point where it ends either. It's an exponential decrease. Most of the air is in this very, very thin layer. That's the example Carl Sagan used to use if you take the globe and you look at the varnish on that globe, that's the thickness of the atmosphere. But that's only true for the high pressure part where we live. But you're absolutely right. There's this distended, very thin part that goes and goes and goes, and there's no point where it ends. It just gets thinner to the point where it eventually becomes sort of indistinguishable from the quasi vacuum of space. But that is a really tough one to get across, but I think the sort of visualization tools that you guys are developing, you can probably, if you wanted to, you could show that to people.
We're looking at the atmosphere of Jupiter, which is very dense. The core of Jupiter, which is more or less Earth-sized, is invisible to us.
Yeah, I really like your question because I think just in general, people need to be more aware of what's up there, what's just above Earth. And, I think as we spend more time on space stations, the International Space Station, and we learn more about that and go up there more, go to Mars, like that video suggested, that's something I really think we should do. I think these things will become more part of what everyone knows. That'll be good.
There's this other crazy structure, which is the Earth's magnetic field, which if you go to, for instance, to the planetarium over here, and there's a good one up here in the in New York City up at the American Museum. It's a good one in Chicago and San Francisco. There's a few others, but I know the New Yorker view. There's the planetarium, but But anyways, there are these visualizations we can do now where you see the Earth, and then all of a sudden you see the magnetic field, and it's like the gentleman was saying, it's this structure that's like so much larger than the solid Earth, and it's also got this weird shape where there's this tail that streams off away from the sun, and so there are all these other aspects of the world that are usually invisible to us, but with these new visualization tools, we can sort of render the invisible visible, and I think it's a wonderful way to kind of help us to understand that we're part of these larger structures that we don't always perceive.
Hi there. So when humans settle on other planets, how do you think they will breathe the air there? Do you think that maybe they'll change the air on the planet, or perhaps the humans will change or be able to change themselves so they can breathe that air? Or perhaps the technology will be, there'll be maybe something they put in their nose that will allow them to breathe the air off the planet.
Well, I think if we shoot Mars with a bunch of nuclear missiles, that will actually do a lot in making the air more breathable. Sorry, that was a joke. I don't know if you guys heard that one guy, I can't remember his name, but he said that. But in seriousness, I think... no, it was the Tesla guy. What is his name?
Musk? Elron?
Musk, yes, Musk. Musk was surprisingly close. Anyway, but in seriousness, I think that it's more likely that we'll change the air. I know that a lot of people have talked about going to Mars and planting, untold fields of moss that will produce oxygen for us.
Yeah, nuking isn't really the best way to do it. In fact, it's a really, really, really bad idea. But I think at first we'll bring an air mixture that we're used to, like we did when we went to the moon. That's what humans have always done when they've gone to uninhabitable places like Las Vegas. We bring water with us. We go to the moon. We bring oxygen with us. So when we go to Mars at first, I think we'll bring, and we can manufacture air in enclosed spaces from native, living off the land from local materials. It's a much longer and perhaps even more technically challenged and perhaps even more ethically dubious question whether or not we should someday try to change a planet like Mars to be a place that we could breathe. It's possible at some point, if we really discover there are no Martians, that we might decide we want to try that. I don't think we should be in any hurry. And it is possible in the very long run that we might even, as you suggested, be able to change ourselves to live in other places. That is also a big can of worms. But we seem to be maybe even in some ways headed in that direction, and it may be easier ultimately to adapt ourselves to other worlds than to try to adapt those worlds to us, if we should choose to try to go and live on them.
Final question.
A question again on virtual reality. I recently heard or read about work that was being done to use virtual reality to help with pain management, and I was wondering how that can be explained.
Yeah, I think I may have possibly saw the same article. Again, I see a ton of these articles, and I think the secret is, and I really don't know that much about pain management. I know that's kind of a science unto itself, and I don't want to sound presumptuous or anything. But what I saw was people who had lost limbs. And what they would do is they would virtually replace their limb. And there's this thing called phantom limb syndrome where you feel a pain in your limb. And what happened was when they virtually replaced the limb, that pain would go away. And this was a type of therapy that they used for people who had lost limbs.
I think it comes back to Sue's point where the mind is actually the most powerful, the imagination is the most powerful tool that we have. So if you believe... if you can find a vehicle to help you believe something.
Is it still on? The example I heard about was the experiment they were doing was having people put their hands in cold water for a prolonged period of time, sometimes without a virtual reality and sometimes with, and they were able to stay and withhold the pain longer with it. So it's not I'm assuming it's the same, mind over matter, but what it is that... How could you explain in the virtual reality that you forget the actual physical reality? How does that even happen?
Yeah, okay, I didn't see that article, but I have used a lot of different virtual reality tools, and I can tell you that you get real feelings out of seeing things. You know, the human senses are very easy to fool. I think just by seeing something and feeling a feeling, you know, a buzzing in your chest or something, you can. It seems like you're there.
I mean, you have to remember your brain is constructing reality. So if the information that it's getting is not coherent, it's picking and choosing, and therefore responding differently based on, you know, are you giving it information that the water is not cold, you know?
Or just the Matrix.
Sorry. But that I managed to give myself the final word. But please, will you join me in thanking these amazing panelists? And then I think Alexis is going to invite us all to drink.
Yeah, so I'm not going to say much. I want to thank Nikki for moderating this discussion, for the opening night. Thank everybody. So we have a Expeditions demo that's outside. We have some Google Cardboard that are available for people that don't want to interact with anybody else, just want to have their own time. But we have 2 bars that I was told, one on each side. We also have a terrace. The weather is pretty nice. I want to thank all you guys again. Nikki, who will be with us for the entire festival, and the Edible Smog will be there on Saturday night at Brick next week.
How to taste the air.
Yeah, taste air. And I want to thank everybody. And again, as Nate was mentioning at the beginning, if you come tomorrow to the visit with any of the articles or any of the elements that are in the gift bag, you come in for free for the event, the visit, which we couldn't have asked for the better promotion, actually, for the visit with all this news about a strange star. Anyway, so the visit, which is the New York City premiere, which will be at the Tishman Auditorium. And tomorrow night we'll have Charles Lindsay, who's the artist in residence director at the SETI Institute, and Summer Ash, who does outreach. Charles, who's here tonight, and Summer Ash, who heads the outreach program at the astronomy at Columbia University. Thank you so much, everybody, and thank you to Google. Thank you to everybody for being here.